Okay, so absolute maxima and absolute minima. The biggest thing here is, remember, I just said this is an existence theorem. So what they're going to do is just basically tell you this is how it is. For an absolute extrema, basically what they're asking for is the largest or smallest y value. Okay, it's very specific. It's the y value on the entire graph. Okay, on the entire graph. So if you think about it, if I'm asking you what's the highest and what's the lowest, we're going from top to bottom or bottom to top. Those are all y values. So you have to give the y value. If you give me an x value, you're not giving me the absolute max or the absolute min. Okay, so by definition, what you do need to consider is an interval in the domain of our given function, whatever it is, and a point x sub 0. X sub 0 is just basically any point on the graph. They just use x sub 0. I think on the concept cards we use C, I think, if you take a look on the concept cards, if you haven't done it yet. So they are interchangeable. C is not a constant. It's just a value for x. That's what we're calling it, okay? And what we say is that f has an absolute maximum at that given value if the y value is bigger or the largest on all those y values for the function. Okay, so we want the largest y value. That's what we're looking for, largest. Okay, and we can say that our function f has an absolute minimum at that given x value if our y value is the smallest for all y values on that interval. Okay, and then this is just a general statement, but it says that the function will have an absolute extremum at that given x value if you have either an absolute max or an absolute min. So that's just in general. Remember, I gave the example of if I'm talking about a polynomial versus a quadratic. So I could say, oh, at x equals 5, there is an absolute extrema. But it could be the absolute minimum. I don't know. Okay, so that's being very general versus being very specific. Okay, so these first three graphs basically have no domain restrictions. Okay, if you look at these graphs, this is implied that there's an arrow here and here, as well as here and here, and here, and here. Okay, it's implied, but I'm telling you that it's there, so that way I don't have to imply anything. Okay, and what we're basically saying is that f has an absolute minimum, but no absolute maximum, and the interval that you're looking at is from negative infinity to positive infinity. And if I were to just give you an example here, let's say I'm just going to make up numbers. These are made up. I'm just making them up because there's no scale on here. Let's say that this is a value at, the point is at 0, 2. Okay, so if you were to be asked for the absolute minimum or absolute maximum, you could say that an answer would be f of 0 equals 2 is an absolute min, or you could say the absolute min is at 2, but you can't say the absolute minimum is at x equals 0, because x is not a minimum or a maximum. Okay? You have to give the y value. So that's really, really important. So in the case of this linear function here, you can see that there is no absolute extrema because, I mean, there's no lowest or highest value. The graph keeps going infinitely. In the case of the last graph, there is both an absolute max and an absolute min. Here, these two values, are they the same y value? I mean, they look like they're drawn in the same spot. So let's say if I gave numbers, if this is -1, -2, they look like they're in the same spot. Do you agree? Okay, and then if I said 1, 2, 3. Let's call this 4. So this is at positive 4. So if I were to ask you for the absolute max, how could you answer that question? I just made up that scale. Absolute max occurs at f of 0 is equal to 4, at 0, 4.
How do you know that when we continue that it might not just go up the axis? Like it just...
What do you mean up the axis? This is the absolute max. Oh, you mean that it's going to keep going like this? It looks as though it's approaching here.
It looks, but how are you sure that it's...
I can't. Here I'm just using, it says that we have an absolute max or an absolute min. So it's just in the picture that we have. Your domain goes from negative infinity to positive infinity. They did not give you a range. So, we can't.
Because if that was the case, you wouldn't really have an absolute maximum if the graph would still be going.
You don't know that, though, so you have to use what you've got.
Okay.
Yeah. Okay, and then what about an absolute min? Do you need to state it twice? No. So in this case, we could say that there's an absolute min at negative 2. Okay, so this is where you have no domain restrictions, and it was pointed out too, how do you know what the graph is doing? You don't. You don't. You're given what you have here, and in this case, it doesn't give you a range, so we have to use what we've got. Okay, now, if you take a look here, we have a domain restriction. All right, in this domain restriction, if you take a look, here these endpoints are not included. And what does this graph look like? I heard it. It could be like a negative tangent, right? Or cotangent, right? It's the same thing. Okay, so in the case here, if we know the behavior, doesn't this go on and on and on? So here we have these endpoints are not included because of vertical asymptotes, so we could say that this is either a negative tangent or a cotangent graph, but there is no absolute extrema on this open interval. Okay, now, if you take a look at this next function right here, e, couldn't this be the same thing as b? Okay, it could be a linear, I don't know, I'm speculating, but what is different about e? Yeah, it has endpoints. Basically, they took maybe a linear function and they just kind of chopped it off and said, all right, we're going from here to here. Okay, so here's one thing that you need to maybe write down, is that an absolute max and an absolute min can occur at endpoints. Okay, a relative max and min cannot occur at endpoints. Okay, so in this case, I could say that this function has an absolute max at whatever that value is, right, for y. I don't know, let's just say 2. And then an absolute min at negative 2, if we kept that same scale. So absolute maxes and mins can occur at endpoints. Can someone tell me why a relative max and a relative min will not occur at an endpoint? Think about how we determine. We just did it in that example before. What do I do? How do I, if I gave you a function, if I gave you f of x and I said, tell me where there is, or provide me with the x coordinates of the relative max, relative min. What do? What's a process? You're given f of x, not a graph. You're given the function. You're given f of x. F of x is equal to 5x cubed minus 6x squared plus 2x minus 1. What do? Take the derivative. Okay, we take the derivative, and then what do we do with the derivative? Set it equal to 0, and then find the critical numbers. Okay, so then we find the critical numbers, and what do we do with those critical numbers? Put them on a number line. And how do we determine relative min and relative max?
Based on whether they're increasing or decreasing.
So we look to see what's happening before and after. If this is a critical number or critical point, can I determine what's happening before?
No.
This is why you cannot have a relative min and a relative max at an. Does everybody understand that? That's why it's important that you understand. Relative mins and relative maxes will not occur at endpoints. You can't figure out what's going on before or after because you don't have any more. Does that make sense? Okay, it's important. Questions? Okay.